In this episode, you will learn what a digital hydrogen plant is and why now is the right time for your company to invest in this technology. It's about the opportunity for you to develop entirely new plants, meet safety requirements, and it's about the tools Siemens offers, the templates available, and the decision aids you receive to facilitate the planning and construction of such plants.
Get ready for Hydrogen, a Siemens podcast with Michael Pretorius and Philip Glaser.
My guest is Philip, and he spends all day focusing precisely on this topic. Philip, why is now the best time to invest in this digital hydrogen plant?
If you understand what digitalization is or want to understand what digitalization is, then we talk about many terms regarding the digital twin and all the great things that can be done with it, how the digital twin and the digital plant simplify engineering, and how it can naturally be used in operation as well. The key to success in digitalization is to take full advantage of the opportunity and potential to truly utilize digitalization from the very beginning. Because if I use it from the very first step and rely on the right tools, then the digital twin is created almost automatically. By performing my regular engineering tasks and responsibilities and utilizing the simulation that I need for essential engineering work anyway, a digital twin is created nearly automatically and effortlessly if the right tool set is used.
And by the way, I'm just imagining that this digital twin is really something like a sort of concept on the drawing board. Is this something different from the hydrogen plant that I can later enter and visit, or is it one and the same, this digital twin or this digital hydrogen plant?
So the digital twin should always be a representation of a specific plant, and it naturally continues to evolve with the plant, supporting, for example, during operation. And while it supports, it also remains up to date. But let's briefly start from the beginning. When I make an investment decision, I usually have to convince some additional investors or financiers, and I need a feed study, a feasibility study. And even at that stage, we asked ourselves how the tools can be used as easily as possible. I'll start with the simulation tool using GPROMs as an example. We've created a library that is so simple, my children could use it right away if I explained it to them. I have a library with the typical components that a hydrogen plant has. I bring them in, quickly set up a small simulation model, and can start playing around with a few values. I can say, okay, how much electricity do I have? How much hydrogen do I want to produce? And then I would easily see how much water I need. For example, I can check if my location is suitable, if I have the necessary conditions and logistics, and with that I can already significantly enrich my basic concept with which I want to convince my investors. And for that, it is of course very relevant to say with which tools are we doing this. When I think of our COMOS tool, a large part of the parties involved in the construction and engineering of a plant can indeed actually work in COMOS. And then a thoroughly complete object-oriented data model of my plant is created. This means I have all the plant data collected in one place in an object-oriented manner, so that through the normal engineering process, which we also call integrated engineering, the digital twin is created almost automatically. This means that at the end of my regular engineering process, without significant additional effort, I have a digital twin of my plant.
Perhaps you could elaborate a little bit more in greater detail on these tools and templates that you mentioned earlier in some way. So, we just talked about the planning, we talked about the later construction of the plant, the simulation, and later the operation, and I have to plan everything anew. It is a first of its kind plant. So, there is nothing yet that has been built, much in the market, that one could have seen for 10 years now. It's all very, very new. Is there still something I can build on?
Yes, of course. So naturally, many technologies are currently new. Think of the various providers of electrolysis, for example. There are, of course, many companies that currently have very innovative approaches, where perhaps the first pilot plants have already been running, and maybe even the first electrolyzers are already operating somewhere. But now we are on the threshold of them being actually produced, manufactured, and also deployed on a larger industrial scale. We asked ourselves, how can we now support these companies, whether it's a manufacturer of electrolyzers, someone who needs to integrate a plant as an EPC, or a plant owner and operator? We asked ourselves, how can we indeed simplify this so that these technologies can be implemented? And of course, these hydrogen plants, even though they are very innovative, when we look at the components, the parts of a plant, We repeatedly talk about similar plant parts, about similar package units. And we just pre-engineered it in advance and said, all right, what could that look like? And have we thoroughly and comprehensively mapped a generic hydrogen plant in its entirety in a digital twin? And the result is practically engineering building blocks, templates, blueprints that are available in our software modules. That means, for example, in GPROMs for simulation, in Commerce for engineering, and they will, of course, never completely fit an individual plant as expected. But of course, I certainly don't have to start from scratch because we have created a fundamental structure, so I only have to adapt many specific things to my individual situation and don't have to do the engineering completely.
That means we are in the planning phase, but later we are also involved in the entire setup of resources such as equipment and components that I need for it. And later on, in the future, they will also have to grow with this digital twin and demonstrate their performance. Will I eventually be able to see if they have any wear and tear or not? Is that how I can imagine this digital twin?
Yes, absolutely. Now you've already moved further, namely from engineering into the operational phase. Yes, so after the engineering phase, we naturally have the situation where we can then move into the commissioning phase. Of course, you can already do a lot with simulation, especially when it comes to being as fast as possible. You can simulate the plant in advance. I can perform virtual commissioning and I can already train my operators in the operation of the plant. But of course, when it comes to the topic of safety, it is naturally a very, very important issue, especially for hydrogen plants, which are also subject to corresponding regulations. If I have now commissioned the plant, then I have an innovative facility in front of me that may already be relatively large. Perhaps we are already talking about 100 or 150 megawatt. And then of course this plant must be further optimized during operation. One must learn what the best maintenance strategies are. How do I effectively deal with the issue of wear and tear? How do I find the plant operation mode that generates the highest possible performance while also being gentle and efficient on materials? And for that we naturally use data. Indeed, we use the digital twin, in which the asset information is present in the digital twin. And here, of course, manufacturers of electrolyzers as well as operators of the plants involved in the process can collaborate in a new way based on a digital twin. Once the electrolyzer is purchased, it becomes the property of the plant operator, who is then responsible for its safe operation. This responsibility includes ensuring that the component is maintained properly and operates within the safety guidelines established by the industry. And then, of course, it must be clarified who will maintain the whole system. If it's the plant operator, they will naturally need a few more data. Or if it's the electrolyzer manufacturer, they will naturally need access to some data. Does the electrolyzer manufacturer perhaps even want to implement some kind of fleet management for all the electrolyzers it has in operation? And so we practically enter the operational phase, where we can also say, for example, an anomaly is emerging here, we detect an anomaly here. We can, in essence, and this is a unique feature of our system, which is a significant advantage, continue to use both the simulation we used in engineering and the plant data tool Comos during the operational phase, and a testament to the flexibility and adaptability of our system, allowing us to seamlessly integrate and optimize operations efficiently. This means, for example, when I come to the simulation software runs alongside the operation, and we then see the deviations between the simulated data and the values from the process control technology, allowing us to do many interesting things. For example, we can determine how the degradation of the membrane is or calculated. And this allows for many insights, especially regarding maintenance, material-friendly operation, and similar aspects.
Does that mean such a digital twin can also provide decision support or make decisions for these entirely new market participants that exist in part?
Absolutely. I think this is a major challenge in many areas where new players and innovative plants are currently coming together, because these innovative electrolyzers, for example, also need to be further optimized for the next generation. Or, of course, one can imagine, for example, such an electrolyzer is in operation and there are, I don't know how many, maybe already 20 or 30 electrolyzers in a plant in operation. And now one of these electrolyzers encounters a problem, for example, with the membrane. What will happen? I can well imagine that the plant operator might say, look, there's a problem with your membrane, there's a material issue. The electrolyzer manufacturer will say, man, no, I don't believe that. It must have been due to the way you operated the thing. That means these are areas where we might see some potential for conflict. which can naturally be avoided if electrolyzer manufacturers and plant operators agree in advance on how to approach it technologically. The topic of maintenance, the topic of operation, the topic of warranty, so that a win-win situation can be created from this impending conflict where the electrolyzer manufacturer has a kind of fleet management and can see and learn what the optimal mode of operation is, but on the other hand, it is also transparent how the operation is conducted. This way, good win-win situations can be created, which might potentially contain various conflict potentials.
What potential for conflict are you talking about?
Well, something like a warranty. So, suppose the membrane is broken, or there's a problem with the membrane, one person claims it's due to the material, and the other says, well, it's because of the way you operated it. Like with a car, you go to the workshop and you say, here, my brakes are worn out after just a few kilometers. Then the car manufacturer will probably also say, well, that's never happened before, it's because of how you drove the car.
And then, of course, this data is completely neutral between these two partners.
They need to agree on this. That's why I say it's a possibility to agree based on the technology. The technology is there. We can offer such possibilities with this technology. And it is, of course, up to the market and the players to shape such things. We have pre-thought such ideas and we have also considered how we can implement them. And we are ready to discuss such topics with the market and to moderate such processes with the players and to see how these technologies can be used as effectively as possible and the potential of such technologies can be utilized. And that's exactly where I see the opportunity now. To your initial question, why digitalization now? We have plants that are greenfield plants. We have innovative players in this market. We have first of its kind plants, and almost all of these plants are expected to grow and be replicated. Typically, several identical plants are to be built. This means there is an enormous potential for scaling. And of course, when considering the scaling potential, I naturally want to leverage learning effects and repeatedly use existing engineering.
Now, of course, on one hand, there are completely new business models that can be conceived, entirely new ways of operating such a plant and ultimately monetizing it, but it first needs to get started. And for many, this is completely uncharted territory they are entering with hydrogen plants. Are there things, like with the safety requirements, there is the topic of security and the topic of safety, two different areas, but let's start with the safety precautions to ensure that such a plant is operationally safe. Are there aspects where a digital twin can already support the operator at the start?
Yes, absolutely. So the topic, especially when we focus on operational safety, is of course the question where several things come together. On one side, there are the correct ones. So when we talk about the safe operation of a plant, many things come together. On one hand, of course, the right technologies. When we talk about safety systems, SES safety instrument system, emergency shutdown systems, which are relevant. Here, crucial tools are essential, such as, for example, the so-called safety matrix, which is a simple cause and effect matrix because there are indeed complex interrelationships. It is not enough in a hydrogen plant to make each component safe on its own and have a safety concept for each component because there are indeed important interactions between the individual parts of the plant. This means I need an fully integrated safety technology. On the other hand, I naturally also need the know-how. And this is an important point where we see, of course, that we have many new players in the hydrogen industry who do not have decades of experience in the field of process engineering for the process industry, where, let's say, dozens of people are not sitting together in a specialized department as we have in the traditional chemical industry. And of course, we have the right people on board. For example, we have in-house TÜV certified specialists for functional safety within the company, so we can provide support not only with the systems, but also in terms of content.
And that does mean you can then look into my digital plant with your experts upon request, or is it more of a preliminary consultation? How should I envision this when it comes to the digitalization component?
So, in principle, it is more about clarifying this in advance and being involved in this conceptual phase. But of course, we also support customers during ongoing operations if needed. We have appropriate services for this. The topic of safety, as well as the topic security, particularly the topic of cybersecurity, is also very important in plants, and naturally during ongoing operations, various services are available to the market, customers, and plant operators.
That means if I do everything right now, it will also help me obtain the operating permit, because ultimately that's the most important thing at the beginning, that I can not only plan the plant, but also get it up and running.
Absolutely. This is something that sometimes worries me a little at the moment because there is occasionally a suspicion. We'll see how the market develops, but sometimes there is a suspicion that the issue of safety is currently being somewhat underestimated because at the end of the day, I need an operating permit for such plants. And of course, naturally, these plants fall under the relevant regulations for process engineering plants, the EC, to avoid getting too technical. So that means if these regulations are not followed, if I don't have a risk analysis or a HAZOP analysis, then I will have great difficulty obtaining an operating permit for such plants.
Can I run this risk analysis using a tool from you?
This is not tool-based, but we can offer such risk analyses. Yes, exactly. So we do those as well.
Then, nothing stands in the way of the hydrogen plant itself. And I gathered that the digital twin is precisely this momentum that is now possible, which was previously difficult to achieve with other plants because you had to digitize something that was initially analog. And with the hydrogen plant, one could suddenly participate, and there is a lot of potential to grow further, even up to the business model.
Absolutely. So let me briefly summarize. We have the capability to supply the necessary hardware and software for the topic of digital hydrogen plants, as well as the relevant know-how and services to generate the digital hydrogen plant. Why is it so important? Hydrogen plants are more similar to each other than others. Chemical industry plants are state-of-the-art, which is why there is the possibility to use prefabricated templates to easily achieve this. Why is it so exciting to have the digital twin? Because the plants expand in scale, electrolyzers, we have many various similar components in the plants. The plants themselves are also intended to be replicated as a rule so that digital plant planning can be easily duplicated. Ultimately, in 2021, there is a lot of efficiency in scaling up my business model. And if I have a digital twin, then I can of course optimize the operation for these new types of plants, and it enables different players to potentially create entirely new business models, offering completely new things in the market, such as the previously mentioned fleet management of electrolyzers. And I think in one of the next episodes, we will then come to the Hydrogen Performance Suite, where we will look at what the user interface is actually like and how I actually interact with a digital twin in operation.
Many thanks to Philip, and if you want to stay updated on this topic, be sure to subscribe to this podcast. I'm looking forward to the next episode with Philip.
This podcast was done by humans but localized with the help of AI. Thanks for listening.